Hello everyone. In today's video, we will do an introduction to matrices and we'll also learn about some significant operations that you can perform and how to perform those operations, which are crucial to succeed in this course. So in linear algebra, a matrix is a rectangular array of numbers. The numbers in the matrix are called its entries. We use square big brackets to denote a matrix. That's a very standard notation. For example, if I give you this array of numbers, this is a matrix. As you can see, the entries are real numbers, and this one has two rows. So this is going to be the first row here and the second row, right? And this one has three columns. So this is the first column, the second column, third column. I can write it like this. This is column 1, column 2, column 3, and on the left hand side I can write row 1 and row 2. It's important that you know the difference between the rows and the columns of a matrix because our whole science of linear algebra depends on it. Now, this is a matrix with 2 rows and 3 columns. The order of a matrix is very important. And how do we define the order of a matrix? For example, for this matrix, the order is 2 by 3 because it has 2 rows and 3 columns. We also pronounce that this matrix is of order 2 by 3. In general, the order of a matrix is the number of rows. In general, the order of any matrix, order of a matrix is m by n, where m is the number of rows it has, and n is the number of columns in the given matrix. Now, we will learn about a few important matrix types in today's video. The first and most important matrix type that you will study in this course is the identity matrix. Now, what is an identity matrix? We usually denote it as IM. Why a single entry as the order? Because it is a square matrix with ones on the diagonal and zeros everywhere else, where M is the order of the matrix. Because it's a square matrix, the number of columns must equal the number of rows, and hence I have only one entry as its order. Now, we'll talk about identity matrix later on with more examples, but I'm just giving you a general definition. For example, if I want to write the identity matrix of order 2, it will be a square matrix. The main diagonal will have 1. Everywhere else, I'll have 0. What is a zero matrix? Zero matrix could be rectangular. Each entry will be 0, right? Just as the name signifies. Any matrix which has all entries 0 is known as a zero matrix. We usually denote a capital O or a big 0 to denote a zero matrix. Now, in general, we use capital letters to denote matrices and small letters for constants. We'll also call scalars. You'll also denote constants as scalars in linear algebra, especially in vector math, in vector, forgot the name for it, vector science. So get used to the term scalars for constants. Now, we've learned about the basic types of matrices and stuff. Now, what are the operations that we can perform on a matrix? The first one, and the easiest one probably, is going to be a scalar multiplication. So you're given a matrix, you multiply the whole matrix by a constant or by a scalar. The most important thing about this is it doesn't matter which side you multiply this constant from. Look here, I've multiplied a matrix A by a scalar C, and which is going to be the same as A times C. The left-hand side or the right-hand side order of multiplication doesn't matter for this operation. For example, I have an example for you here. I have 2 times this matrix, and as you can see, each entry gets multiplied by 2. Similarly, I have another example where I'm multiplying negative 10, which is a constant, a scalar, by a, what is the order of this matrix? How many rows do I have? I have 3 rows, row 1, row 2, row 3, and I have 2 columns. This is a matrix of 3 by 2, right? The resultant matrix will be of the same order. Scalar multiplication does not affect the order of a matrix. Same thing here. This is a matrix of order 2 by 3 because it has 2 rows and 3 columns, right? And this is a scalar. The second operation that we learn is matrix addition and subtraction. It's also very straightforward operation. One thing that you have to keep in mind is the matrices must be of the same order. Otherwise, the addition and subtraction of the matrices will not be defined because we perform entry-wise operation. Let's see this example. It will make it more clear. I have 2 matrices. Notice one thing. This is a matrix of order 2 by 3, another matrix of order 2 by 3, and I'm adding the 2 matrices. So I add each corresponding entry, and the resultant matrix is also going to be a matrix of order 2 by 3. We can similarly do the subtraction as well. We can perform the subtraction. I have a matrix here which is of size 2 by 2, another matrix of size 2 by 2. I perform entry-wise operation, so 3, negative 2, 4, negative of negative 1. And as you can see, the resultant matrix is also of order 2 by 2. So it's very important that the orders match to perform a addition or subtraction on 2 matrices. Another example here, I have 2 rows, 3 columns. I have 2 by 3, and I have a matrix which is 3 by 3. As you can see, the orders don't match. I cannot perform entry-wise operations. Hence, this sum is not defined. The last and the most important operation that you learn in today's video is known as the matrix multiplication. The most important and the most complicated operation that you can perform on a matrix is the matrix multiplication. Now, I'm not going to dive into an example here. I just want you to understand the science behind multiplying 2 matrices. You have to understand how the orders work. The orders of 2 matrices must be compatible in order, if we want to multiply them, right? So I have, for example, 1, I have a matrix A of order m by n. M and n are integers, positive integers, right? Because you are only counting the number of rows and columns. You cannot have negative, you cannot have fractions. B is a matrix of order n times p. What happens when we say the orders are compatible, you see the common term here. So this gets dissolved when you multiply 2 matrices, and the resultant product would be of order m by p. So matrix multiplication can affect the order of the parent matrices. Let's look at another example. Now I have n and m. So the number of columns in A does not match the number of rows in B. This matrix product is not defined because I cannot dissolve this middle term. It's very important, right? Let's look at another example. I have number of columns here is P, number of rows here is also P. They will get dissolved and I can perform the matrix multiplication. The resultant order would be m by n. Order of 2 matrices is clear when we multiply them. Now let's look at a working example. So I need to do this from scratch for you to be able to understand this. I'll take a easier example. Let's see one that works. Because if it doesn't work, then you can just say the matrix product is not defined and leave it at that one line, right? So I need to give you an example that works. Suppose I have 1 matrix 2, 1, 0, negative 1, 0, 1, and I have This is a matrix of size 2 by 3. I have 3 columns, right? And let's pick another matrix. I have 4, 2, -1, 1, 0, 2. And this matrix is of size 3 by 2. I have 3 rows and 2 columns, right? Can I perform the matrix multiplication? That's the first question you should ask yourself. And if I can perform the matrix multiplication, what would be the resultant order? There are steps for this question, right? Step 1, can we perform multiplication? Multiplication, right? If yes, what would be the order of the resultant matrix? What would be the resultant order? In this case, I can perform the matrix multiplication because the 3 will get dissolved, right? The number of columns here and the number of rows here, they match, so they'll get dissolved, and the resultant matrix will be of size 2 by 2, right? Now you move on to step 2. The resultant matrix would be of size 2 by 2. Great. What is step 2 now? Now, this step is only for students who are new to matrix multiplication. This is all new to you, and you just want to make sure that you don't make any mistakes in exam. This step is for you. To avoid any error, I want you to write down the strategy first. So you are multiplying. This is how I want you to remember this. So you're multiplying row 1 with column 1, and that's going to be your first entry. Row 1 with column 1, and then again you're multiplying row 1 with column 2. And same thing here, you're multiplying row 2 with column 1 and row 2 with column 2. Only do this if you want to be extra careful to not make any mistakes, especially when you're doing the first 10 examples of matrix multiplication. I highly recommend that you apply this step. Now, what do I mean when I say multiply row 1 by column 1 and multiply row 1 by column 2? This is for you to focus on which rows I want you to focus on for this particular entry. Now, we can calculate this step by step. Let me just reduce the screen size here so I can see the entries. So when I say row 1, column 1, this is how you calculate it. So you're taking row 1 of the first matrix and multiplying each entry with the corresponding entry in column 1 of the second matrix. So I take this row and this column and I multiply entry-wise. So I'm doing 2 times 4 and I'm adding everything. And then I'm doing 1 times -1, and then I'm adding, well, the last entry is just 0 times 0. There you go. So I got 8, -1, I got 7. And that's going to be my first entry here. Same thing, I find row 1, column 2. I focus on row 1 of the first matrix and multiply each corresponding entry to the column 2. So I'm multiplying row 1, which is column 2. First entry is this. Add. The second entry of row 1 is 1. Second entry of column 2 in the second matrix is 1. Plus. Last entry of row 1 is that. Column 2 is 2. So this is clear. And same thing here. I should say this one. So this is first matrix, and this is second matrix, right? Now, let's calculate each other entry. Now I do the same process, but I do it for row 2. So row 2 and column 1 would be -1 times 4 plus 0, because 0 times -1 is just 0, plus again I have a 0, I got -4, right? Next, last entry, I have row 2, column 2. I'll have -1 times 2 plus 0, right? And then I'll have 1 times 2. So I got 0 again. So as you can see, I have calculated all the entries, and that's my final answer. There you go. So the first entry is 7, second entry is 4 plus 1, 5. This is -4, this is 0. And this is my product. There you go. You can repeat the same process for bigger matrices. Add as many steps as you like, as long as you're comfortable with matrix product. I'm going to do one more example. I will not complete it. I'll leave it for you for practice. You can find multiple videos on matrix multiplication on YouTube. This is just from your instructor. Now I have another matrix for you, 3, 0, -3. I have 1, -1, 2. I have, let's say, I'm making it up as I go, 3, 0, okay? This is a matrix of order 3 by 3, right? It's a square matrix. I'm multiplying this matrix by this. I have -1, 0, 2, 2, 1, 3. It doesn't matter really. So first question you ask yourself, can I multiply these two matrices? If yes, what's going to be the resultant order? Ask yourself that question. You can only perform matrix multiplication if the number of columns and the number of rows match here. And they do. So the resultant order would be 3 by 2. And what is the strategy? I'm taking row 1 and I multiply it by column 1. Because you'll have 3 rows, it makes complete sense that I'm going to multiply row 1 with column 2, right? I only have 2 columns. Row 2 with column 1, row 2 with column 2, row 3 with column 1, row 3 with column 2, right? And this gives me the right order of my matrix. And if I want to calculate, for example, row 1, column 1, I'm taking row 1 of the first matrix, multiplying entry-wise with column 1 entries, right? So I get -3, and I'm doing it a little bit faster, but I hope you can catch up. Multiplying entry-wise, you got -6. I'll do one more. Row 1, column 2, I'm again focused on row 1 of this matrix, but I'm now focused on column 2 here. The first entry would be 3 times 0, 3 times 0 plus 0 times 2 plus -3 times 3, I get -9. And similarly, you find each other entry, and there you go. That's your matrix product. I want to mention one more operation that you can do with matrices, which is important. It's not involving two matrices, but it's just an important operation that you can perform on a single matrix, which can be useful, is matrix transpose. Now, what do I mean by matrix transpose? It's just reversing the rows and the columns, basically. It's denoted by a matrix with a capital T, okay, as an exponent. And how do I do this? Is a reversal of row and columns. Okay? So if I give you a matrix A, let's say, and I say 3, 2, -1, 0, 1, -2. This is a matrix of order 2 by 3 because I have 2 rows, 3 columns. Then its transpose will be, you just flip the rows becomes the columns. So I have 3, 2, -1, and the second column would be 0, 1, -2. And you can see that the order also flips, right? So the rows becomes the columns and the columns becomes the rows. rows become columns, and vice versa. Vice versa. Order also changes if A is of order m by n, then A transpose will be is going to be of order n times m. So you kind of reverse the order as well, right? And this is it for the intro of matrices and some basic operations that we'll perform. There is no division of two matrices, okay? If you ever talk about dividing two matrices, that's wrong. There is no such thing. I will leave you at this note. There is no such thing as division of matrices. There is no such thing as division of matrices. But we can cancel matrices out using inverses and identity matrix. I will talk more about that in our next video. See you in the next video.